So answer
So
did
this
not
was
come, sir.
number 22. Yes.
The answer is not coming.
Which number? Answer is not
An-
coming.
yes, sir.
Okay, answer may be wrong. 30 degrees there. H2 is L by 2 cos theta. That is also correct. Yes, correct. No, no problem. Hmm. This way only we have to. Next one. Yes. No. Till now only you have done this much.
Twenty-nine, sir.
Number 29. 29 says a particle of mass 40 grams slide along a track with elevated ends and a flat horizontal bottom. Okay. At the slides where the horizontal portion begins, a spring is kept. When the particle falls from the height and reaches, it gets compressed by this much. What is the spring constant of the spring? Assume that the track and they are frictionless. Okay. So here you are given. So there is a track like this, and after that it has become horizontal like this. So there is no friction. Track is smooth. Here is one spring. So when an object starts sliding from here, that object may be of any shape, it starts sliding from this top. Here it is coming, and then means here potential energy will be lost, kinetic energy will be increasing. So kinetic energy will be there, and when it comes at this place, what is happening? It strikes the spring. As a result, this spring is now compressed. So spring has come like this now. So this is 19.6 centimeter. The spring is compressed by a distance of 19.6 centimeter. Yeah. Okay. So what is happening here? How will you solve this problem? So whatever potential energy of this ball was or ball object was, same will be the kinetic energy when it strikes the spring. Now after striking, the energy is transmitted to the spring and is stored in the form of potential energy. So whatever potential energy here, same will be kinetic energy before striking the spring, and same will be the energy stored in the spring. So indirectly what will be? Potential energy stored in the spring will be equal to loss in potential energy of the object. So if this object is falling from this height h, And what will be this half kx squared? Spring constant you are asked. X is given. The compression. This x is given 19.6 centimeter. So this half kx square must be equal to mgh. So this k you are asked. Twice mgh over x square. This much simple formula. So here mass is given 40 gram. G you have to take 9.8. And H is not given, so it is something missing. This H will be given in the exam. So if H is given, then only we will solve. 29 we will solve. Okay, they have taken H equal to 19.6 meter. Then you will get what is the answer given there. So this K will be twice into 40 gram, that is 40 into 10 minus 3, 9.8 into 19.6 meter by 19.6 centimeter, that is minus 2 whole square. So this much Newton per meter will be the spring constant. So you will get 19.6 cancel, 19.6 cancel, minus 4, 400. So 400 Newton per meter. Same answer, that is, this one will be 19.6 meter. Okay, next one. Yes. No one. Now, one more thing which is mentioned in the syllabus, but it is not given in the book, that is collision in 2 dimensions. Practically, what will be when one ball is placed there or one marble is placed on the floor, if other marble is striking that first one, they are not moving in the same line. One is going left side, other is going right side. So generally, their motion is not in same line. So what will be? How will we discuss, or how will we find, or how will we solve this type of problem? Maybe elastic collision, maybe inelastic collision, whatever it is. So all the properties are same. That is, if the collision is elastic, kinetic energy will be conserved. If collision is inelastic, then only we will apply law of conservation of linear momentum. So suppose one ball is coming from this side, this way. Other ball is moving from this side, okay, this way. So what happens? Suppose by the time when it reaches here, this ball also reaches here. So these two balls are striking each other, that is colliding. after collision, one ball starts moving this direction, other ball starts moving this direction. Then how will you solve this type of problem? This is M1, this is M2, this is moving with velocity U1, this is moving with velocity U2. This is V1 and this is V2. So the direction of this, suppose first one we are taking the reference line. Okay, this is our reference line. That is one axis we are considering this one. This is our positive x. And other is our positive y. Okay, this one is our positive y. We can take this one as positive x, this one as positive y, no problem. So along one of the ball, one of the direction, we will take one axis. And we will apply the law of conservation of linear momentum along x-axis as well as along y-axis. So if we apply law of conservation of linear momentum along x-axis, what we get? Momentum after collision sorry, and momentum of the system before collision. That should be said. So if we break it into component, what will be? One will be this, suppose this is M1, B1, this angle will be given, okay, alpha, and this angle is suppose beta. Is from the same reference, x-axis only. So M1 B1 cos alpha, this will be M1 B1 sin alpha. M2 V2 cos beta, and this side is M2 V2 sin beta. This is along x-axis only, it has no y component, whereas this one M2 U2 this angle will be given. Suppose this makes an angle of theta. M2 U2 cos theta so if we apply law of conservation of linear momentum along x-axis, then what is that? These two will be the momentum after collision, and this will be the momentum before collision. So M1 V1 cos alpha plus M2 V2 cos beta will be equal to M1 U1 plus M2 U2 cos beta. All are along x-axis only. Similarly, if we apply along y-axis, what will be? This is your positive y, this is negative y. So we will get M1 V1 sin alpha minus M2 V2 sin beta must be equal to M2 U2 sin theta, because this one is 0. It is moving along x-axis, so its y component is 0. So these are the two equations which will be valid for each type of collision, whether collision is elastic, whether it is inelastic, whether it is perfectly elastic, inelastic. whatever it is. So this will be valid for all. If it is perfectly inelastic, naturally both will be moving in one direction only, whatever the direction will be given. So we can apply this law of conservation of linear momentum when the collision is taking place in 2 dimension also. This is mentioned in our syllabus, so we should know this, but it is not given in the book. Okay, so next we shall start the new topic then, as you don't have any problem. So next we shall start the concurrent forces. That part we call statics. So here, particle is in the position of rest. What will be the condition for these all? Yes. Whatever, anyone have